we have been discussing about the soil constituents. And I had talked about solid phase, liquid phase and gaseous phases, and we were discussing the organic matter in soil. So, one of the biggest issues with organic matter is that if organic matter is present in substantial matter, so as the OM increases, I use normally this sign, alright. So, as this content increases, this becomes more and more problematic for geotechnical engineers. So, later on you will realize that the more the organic content in the soil, you can't even modify this. So, those of you who might get a chance to work on ground modification or soil stabilization, these are big subjects. So, I am not going to go into the details of these. But those of you who are very curious to learn about it, please do Google search and you will get a lot of information regarding soil stabilization and ground modification. These are the techniques which are nowadays used for making infrastructure in the challenging and problematic soils, as I discussed the other day. Peat is the most notorious thing. Peat, humus, we had discussed about the muskeg also other day. So, these are the soils which have posed a serious problem to the professionals. So, higher the organic matter, the problems become difficult to stabilize. The big issue is that as the organic matter increases, the soil will not react with cement. So, most of the marine clays which have a substantial amount of marine clay as organic matter, it's very difficult to stabilize them. But I am sure you must be seeing in contemporary world most of the stabilization or most of the construction is going on in the coastal regions. Government of India Sagarmala project is a very good example. So, all along 11,000 kilometers of the coastal line, they are trying to create infrastructure. This is just like, in Hindi you call it daldal or in English you call it muck. And the other day somebody was sitting here and he was someone else, I do not know. So, you were talking about muck, remember maybe first or second lecture. So, this is the type of the soil which is very difficult to negotiate with. So, most of the construction which is going on in the coastal region requires a stabilization. One of the ways of stabilization would be grouting. Why I am teaching you all these things at undergraduate level is that these are the subjects which have to be practiced by people like you. Many of you say there are no jobs. I can assure that there are so many jobs, there are so many specialized things to be done which cannot be done by the right guys. So, these are the areas in which you can think of exploring the possibilities. Another issue is that this material has a very poor shear strength. And very high compressibility. All right. The next constituent of the soil would be, yes. water, and this was what number was the water in the list of constituents? 4, 5, this would be 5, alright. Very soon when we will realize how water influences the overall characteristics of the soil, when we will discuss these things in details, you will come to know that water is the component or the constituent of the soil which controls its all engineering properties. And when we talk about the engineering properties, these are mostly shear strength, this is what I will be discussing in the second course. Shear strength is a dedicated chapter, maybe I will spend about 16 to 18 lectures on defining and how to determine the shear strength, a big subject in soil mechanics. The compressibility, and hydraulic conductivity. And when you come in the domain of the research, you will realize all sorts of conductivities would depend upon the moisture content, including how heat migrates in the system, how current migrates in the system, how electromagnetic flux will migrate in the system. Well, this is the beyond the scope of undergraduate soil mechanics or geotechnical engineering. I will not be discussing this. This is a recent discussion in geomechanics. We call this as a flux migration. And the flux could be of thermal, electrical, electromagnetic, it could be bacterial, it could be whatever you may think of, a combination of the two, and this forms the coupled phenomena. In Western world, a lot of people are working in these areas, they have a lot of funds and they want people like you to join their research groups. So, situation is not so bad as you think. Here shear strength is basically the strength of the soil mass once it gets sheared. So, suppose if I take a piece of paper, alright, and normally the word which you use is tear, alright. So, what I am doing, look at the motion of my hands, the motion of the hands is in opposite direction, clear, one, and this is on the other side, it is a tearing process, but tearing itself is initiated because of the shearing at a plane. And as I said, this is something which is to be discussed separately. When earthquake comes, this is the strength which is required in the material, otherwise everything will become like liquid. You remember we were talking about the liquefaction of the soil, that the soil behaves like liquid. Okay, so here we use another term because of the presence of water, we call this as PWP, pore water pressure. Which is very equivalent to the blood pressure of the human body. So, what happens? Suppose your blood pressure shoots up, you see somebody and you feel very angry, annoyed, hyper active. So, what happens? You start sweating, your blood your blood vessels immediately throw a lot of blood on your face, face becomes red, and if blood pressure shoots too much, what is going to happen? You collapse. Same thing is going to happen in soils also. If by any chance the pore pressure becomes extremely high, the system becomes a critical patient to be treated by a surgeon, alright. And what are the surgeries? These are the surgeries. Either I will modify the situation or I will enhance the properties. Other way, low blood pressure, what happens? Most of the people collapse because of the low blood pressure also. So, this pore pressure is a very tricky thing. In geomechanics, most of the time the pressure will develop in the soils in the pores. We will be talking about what are the pores, clear. So, most of the time the water pressure develops in the pores because of the external loading. A good example would be there is a railway track and there is a train of let us say 45 bogies. Politicians would say that we will make it 55 bogies, 65 bogies, 100 bogies, is it not? And geotechnical engineer says no, it is not possible to have more than 45 bogies. Why? There is an answer to this, because the railway tracks have been designed in such a manner that when the rails move, the type of pore pressure which is going to develop will sustain the external loading appropriately, clear. From here comes the, or from this is the starting point of the professionals like you who might get converted into earthquake specialist, soil dynamics. You will be dealing not with the static situations, you will be dealing mostly with the impact, vibrations, movement of vehicles, movement of traffic, missile coming and hitting a shielded object, is all dynamic cases, clear. So, I will be very interested in seeing that these type of situations how they are going to enhance or decrease the pore pressure of the material. The logic is, or the funda is, if I am dealing with the coarse grained materials like sands, gravels, clear, even if the pore pressure develops, it will dissipate fast. There are guys who are very sensitive, you say something, they will immediately cry, after that everything becomes normal, 2-3 minutes, they forget everything. So, these soils which are coarse grained are blessed, they dissipate pore pressure which gets developed because of the external loading quickly, hence damage is done less. On the other side, there are guys who keep everything in their heart and mind. So, you say something today and the reaction will come after 5 days, there are personalities, correct. So, most of the fine grained materials would have a severe problem of pore pressure developing because of the external loading. So, suppose if I am doing a railway track in the coastal belt from Bombay to let us say Cochin, alright, where you are passing through the marine clays, you have to be very careful about this pore pressure, you have to dissipate it, clear. If this remains inside the system and it becomes very high, there will be a loss of strength, as I said people may collapse, okay. Normally we will be talking about these things in details when we discuss consolidation mechanism. It is a phenomena where if I apply the load, the pore pressure develops immediately in the soils, and then depending upon the material property, the type of a person, you have to wait how long this guy takes to release all the emotions, clear, to release all the pore pressures, and then we will model it accordingly. So, this is something which is we will be discussing for at least 3-4 lectures minimum. So, logic says if you apply if you applied the external loads, alright, the pore pressures will build up. So, the moment external loads are applied, the pore pressure goes up, okay. Now, as a surgeon, as a doctor, as a professional, as a knowledgeable person, I have to tackle this situation, how best I can tackle this situation. One important thing about the water is that water cannot take shear, is it not? Is this correct? Water can be only compressed, it cannot be sheared because this is a property of the material. So, imagine the soils which have enough moisture in them, we are discussing about the water. Water is also sometimes known as moisture content, alright. So, the more the water, more the moisture content, the chances of pore pressure getting developed in fine grained soils are higher as compared to the coarse grained soils. The moment you externally load it, pore pressure becomes very high, strength is getting lost. The question is what water is doing. Water takes only compression or the compressive loads. It cannot take any shear stresses. In fact, more the moisture content, more the water content, the shear strength is going to be absolutely less. And that is the reason if you go and enter into a marshy deposit, chances are that you will sink, you can't walk. Clear? I gave you this analogy in last lecture also. You are on a beach and it is a dry sand, and if I ask you to run, you can't run. But suppose the sands become wet and you can drive the car also on that. Next time when you go to Juhu Beach, please try this, then only you learn soil mechanics. So what water does? Water reinforces the material also. It acts as a reinforcement what you are using in the concrete in the form of the rebars and the steel. So the more and more water which is present because of the capillary action gives more shear strength. So water is the main thing, and we have to study quite in details how it has to be modeled. Water is the carrier of the dissolved salts, minerals. Alright. Now I think you can realize this. If I want to stabilize, if I want to modify the soils, what I will be doing? I will take some cement slurry, water is the carrier, and I am injecting dissolved salts into the system to make it strong. Very similar to the one which doctors do by injecting a ampule or something injection in your body if you are having some deficiency or if you are having some disease and so on. There are a lot of similarity between all these things. Now it so happens when we talk about the dissolved salts, there are few passive salts, there are few active salts. So carbonates, bicarbonates, sulfates, chlorides, these are the ones which are naturally occurring in the water, and this gets impregnated. I hope you understand the word impregnation. Impregnation means they become a part of the system. So they get impregnated into the soil, and hence soils would have salts coming from different agencies. So for that matter, if you take a sample from Powai Lake, or let us say from Bay of Bengal or anywhere from water body, if I squeeze out the soil and whatever solution comes out is just like the reflection of what type of problems the soils would be having and how to treat them. This is what is known as pore solution sampling, the way the blood sampling is done from your body. Doctors and pathologists take few drops of blood and they give you all parameters, correct. So similarly, I can take out some part of the pore water, I can analyze, I can diagnose the problem. So this is a big science and big work which is going on everywhere in the world. This water is also responsible for soil water interaction. Alright. That means look at the dams where you are storing water. So there is no fun in creating a body of the dam through which the water percolates all the time. I can't store water then, is it not? So the whole idea is that I should be storing water in a embankment or a dam body which is impervious. So when soils come in contact with water, there is an interesting interaction which goes on. Some of you who will be going for higher studies or in profession, you will realize soil water interaction. This could be soil structure interaction, this could be soil fire interaction, this could be soil microbial interaction, this could be soil what else it could be, soil contaminant interaction, very nice. So keep on replacing or adding terms to this and this becomes an interaction problem, and interaction problems are mostly solved by the concepts of mechanics. Is this part okay? Then comes the air. Air and water, these are opposite to each other. So if water gives shear strength to the system, the more and more air, if it is present in the soil mass, the system becomes first of all unsaturated. So suppose if I say that soil mass has a lot of air in it and very less moisture, so this becomes the state of unsaturated soil, and this state of the soil I am not going to discuss in third year soil mechanics or geotechnical engineering. Those of you who are interested, please visit my lab, see what are the special equipment which are required to model the unsaturated state of the soils. Is totally different world altogether, and I am not going to cover this here. So, this is the unsaturated soil mechanics or mechanics of unsaturated soil. But please remember, this is more realistic than the one which we are going to discuss in the entire course, because what we are going to discuss is a simplification of the real life situation, which is extremely complicated, because the dynamics of the air inside the soils is going to be extremely complicated, and you require different tools to study this or measure this. Sometimes this is also known as Weddow's zone. Many of you who go for summer trainings and internship, and particularly those of you who go to France, I mean, I get the feedback that we are not teaching you guys properly. I get most of the feedback from different parts of the world about our students. So remember, this subject is also known as Weddow's zone modeling. So if you end up in ENPC or EPFL, Switzerland, so there nobody understands mechanics of unsaturated soil. This is what is known as the Weddow's zone. Sometimes they write it as Weddow's also, both are correct, do not fight with them, alright. Weddow's, V-A-D-O-S-E, Weddow's or Weddow's. Sometimes we also call this as a partially saturated soils. There are different names given to this. Partially saturated soils. Sometimes people also call this as variably saturated soils also, alright. Those of you who may get a chance to work in nuclear industry particularly, or the thermoactive structures which are being talked about these days, the entire West is doing a lot of research on energy geotechnics. I think I talked about this earlier. So, this is where you will be using all these terms. So, what happens if a saturated soil mass, if you start with, it comes in contact with the heat flux, what is going to happen? The water present in the soil will get converted into air phase. Is this correct? So, at elevated temperature or pressure also, I hope you understand this. So, I have created two situations. If I elevate the temperature of the soil, the water which is present in the soil pores will try to get converted into vapors, and these vapors will migrate. Second thing is, what I have to do with the pressure? I have to drop down the pressure, I have to increase the pressure. Drop down the pressure, you are right. So, then what is going to happen? All your points which you have studied in chemistry and physics, sublimation point, freezing point, vaporization point, all what else? Salt concentration point, all those can be applied over here now. So, look at this, see simply what I have done, I have just used two terms and the realm of the subject. Realm means the regime, the scope of the subject changes completely. Are you realizing? It is a very interesting material. So, the moment you heat it up, or suppose if I say no, I am going to freeze it minus delta T, the connotation changes completely. So, those of you who might go to Canada, Germany, all this western world where most of the time the soils remain frozen, this becomes the frozen state of the soil mechanics, correct? Or frozen state of the soils, and what is the mechanics of that? Arctic regions, polar regions, a lot of research is going on in this area. In our own country, in the northeast, in the Himalayan reaches, there are a lot of research centers which are doing research on frozen state of the soils. So, please remember, we are not talking all these things in detail because these are the research ideas. This is okay? Any question? Now, when you are doing this, water to air, the saturation is decreasing, water saturation is decreasing. When you are heating it, delta T, let me create two situations out of it. So, delta T is positive and this is negative, alright. So, in this case when it is delta T is positive, you are doing heating, the saturation of the soil is going to change, and when you are freezing it, we talk about the saturation of ice content or ice content in the soil. So, depending upon the regions in which you are, you have to establish the material properties accordingly. Is this part clear? Anything else you like to add, Dr. Vikas? Is okay? In second semester, whatever I am speaking right now in a theoretical manner, this will be quantified. You got it? So, right now these are the concepts, and quantification of these concepts will be done in geotechnical engineering too, provided I teach you. Otherwise, you will learn the way you can. This also opens up interesting concept. Check on net who are the guys working on THMC, thermo hydro mechanical coupling, chemical coupling, thermo hydro mechanical chemical biological coupling. So, you have a lot of scope for practicing geotechnical engineering, alright. The application comes here. Read this whenever you get time, please read this. And I am sure once you go into the applications part, you will realize how much powerful these subjects are.
Sir, what happens to the shear strength if air content increases?
Oh, very nice. This powder pressure which we are talking about is a component of two types of pressures. One is the water and second one is the air, alright. So, as long as we deal with the conventional subject, we say that there is no air by forcing the material to be saturated, remove all the air, but in real life it is not going to happen. So, this water will contribute UW powder pressure and this will contribute to U air. So, the correct modeling of the soils would be when you measure this also, compute this also and take it into your account, but for God's sake please forget about unsaturated soils right now. Is this okay? But now you are much ahead of your third year, fourth year status, like these things people do not know even at the PG level, believe me. But once you know this, now you devise several equipment so that you can measure pore air pressures directly, and these experiments are very, very expensive. Our lab has all these facilities. Okay. So, another phase, or the constituent of the soil would be minerals. What are the minerals which are present in the soil? The logic is same as I said last time, if you have minerals in the soil, it is just like the minerals in your body. Particularly for those of you who are very much eager to be good industrialists or good researchers, interdisciplinary practitioners. So, for all of you, this is going to be useful. See, the first thing is that minerals are to be identified and later on they have to be quantified. The characteristics of the soil would largely depend upon the type of minerals it has, and I hope you can realize that most of the minerals could be a genetic link between the soils and the rocks. Somebody asked this question long back. So, the way the weathering has occurred, the way the transportation has occurred, the way the mineralogy has changed over the years, millions of years, clear, the system is going to behave or perform. So, many people you will find, if you go to our science department, Kanchan Pandey type of professors, what do? They do dating of carbon. They want to understand how this planet was formed. If this meteorite has come and hit somewhere here, how many years back this happened, what type of soil get created, what is the after effect of this. I think I had shared one of my articles also on lunar crater. This is what is happening. A lot of NASA guys are quite interested in this type of research, mineralogy, Martian, geology, what type of minerals are present on Mars and so on. So, first thing is identification, second is quantification, and third would be correlation. This is more of a doctor's profession, is it not? You do the diagnosis first, identify by symptoms or by doing diagnostic tests, quantify the problem since how many days you are having this symptom, and then remediation, correlation, understanding the issues and so on. So, it so happens that most of the elements of which the crust of the earth is constituted are listed over there. So, these are the elements of earth. Normally, please get some time to go through the facilities which are available in IIT Bombay, very unique facilities. These are known as XRD, XRF, SEM, go to SAFE sometimes. If you want, one of them can coordinate your visit. So, you take the sample of the soil and put it in this type of equipment, do the analysis, and you will find that these are the elements which we are interested in. We call them as percentage by weight: oxygen, silicon, aluminum, iron, calcium, sodium, potassium, magnesium and others. Alright, and what you will notice is that oxygen, silica and alumina would constitute about 80 to 90% of the everything. Where these type of investigations become important in a profession like me, where something has failed, contractor has used the wrong material and I want to catch him, this has become a legal case where I have to submit a report in the court that well, all these things went wrong and hence he should be penalized, the damages should be charged and so on. All these type of negotiation, arbitration which are happening in the court of law, people like you and me have to help the court. So, this is what is known as elemental nonsense. All the minerals are containing these elements, number one, clear. Now, we have to talk about the atomic structures. You thought that after 10+2 chemistry and physics, this is not going to haunt you ever. It is not like this. The basics of the soils are, again the atomic structure of the material. So, the clay minerals are made up of two distinct structural units. The first one is known as tetrahedron and the second one is known as octahedron. You must be aware of all this in chemistry courses, you must have done, clear, tetrahedron and octahedron. So, there is nothing difficult to study. Silicon is here, look at the atomic size 0.26 nanometers. You have silicon at the center and then 4 oxygen atoms, clear. And then when you have aluminum octahedron, you have alumina or magnesium and followed by either hydroxyl ion or it could be oxygen atom. Is this correct? So, these are the basic units. Rest of the things is the combination of this. So, we have octahedron, we have tetrahedron and combination of these are going to form clay minerals. So, this is the tetrahedral sheet. Remember the spelling tetrahedron and tetrahedral. So, when several units of tetrahedron sit together, they form a tetrahedral sheet. So, look at this, this is sort of a bridging, So, what is going to happen in the holes which are getting created? These are the parking lots. Other day I gave you an example about the skin care. So, you use clays and you put them on skin and then you peel them off. So, what happens? All your sweat, negative charges which are present on the skin, bacteria, it gets removed. Why? Where they are going? Parking places, holes. Now, these holes are also very responsible for accommodation of water molecules. So, suppose if I want to make a metrogel, the basic structure of the mineral will remain same. I will create more and more hexagonal spaces, parking lots where the water molecules will go and sit because of hydrogen bonding. I can replace this water by ions also, potassium chloride, hydrochloric acid, calcium hydroxide and so on, whatever. It depends upon in what profession you are, clear. So, these are the places where most of the ions will go and sit. So, the more and more ions which you can pack into this space makes clay a zeolite, and then it has a medicinal value, then it has a chemical value, then it becomes a, what do you call it, as catalyst. You add catalyst for different processes, alright. So, it is all the parking place which you create by synthesis in the laboratory which is going to create this type of situation. Next, for the sake of simplicity, this is how we denote the sheets. So, a tetrahedral sheet is normally depicted like this, alright, rhomboid and silica, because remember there is a third dimension also associated to that which goes up to infinity. So, all these minerals will be having infinite length as compared to their thickness and the height, and this is the alumina octahedral sheet, yellow color, clear. Now, the question is, suppose if you are making the turfs for cricket pitches and cricket control board will ask you, give me a soil which should behave like this for 5 days or for let us say 1 full day T20 match. Water holding capacity is the most important thing. That means these minerals should be holding the water despite all mechanical damages which the system is undergoing, despite all the mechanical impacts which system is going to undergo, clear. When you throw a ball, it is of some weight, momentum transfer, water coming out of the plates of, we call them as plates also, very thin sheets. So, you have to design like this, clear. Then somebody says on the pitches I will have grass also, alright. Somebody will say no, this pitch should not have any grass. So, what type of minerals are going to present which are going to act as a nutrients for the vegetation is also a very important question. I can feed all these things and I can do engineering with the minerals. So, this is a new subject in our realm, our zone, our interest, where you can create different type of minerals for their different requirements. Now, see what happens if you have different clay minerals. We can create either kaolin or halloysite. This is the first group. This is the clay mineral. Most of the powders which you use, white color, be it in washing powder, be it in soaps, detergents, anywhere, toiletries, cosmetics, all kaolin, alright. What powder does? It absorbs sweat, clear. So, these minerals would have some capacity. There is an octahedral sheet and then on the top of this you have a tetrahedral sheet, this becomes a kaolin or halloysite. Sometimes this is also known as 1:1 clay, alright, 1 silica 1 alumina, combination of the two, this becomes kaolin or halloysite. Sometimes we have 2:1, so we have 2 tetrahedral sheet, 1 octahedral sheet, composited into this system. Those of you who are very interested in this, please read. It is a typical structure of kaolin, and I am sure you will be surprised to see what are the applications of the kaolin. Read this which I have written over here. Kaolin is used for making paper, paint, pottery, cosmetic, toiletries and in pharmaceutical industry. These industries cannot survive unless an expert geotechnical engineer is there to help them. And then later on comes the extrusion process, which is nothing but your shear strength parameters. Go to a factory where the biscuits are made, or chapatis, the way the chapatis are done. So, what you are doing, you are rolling them and then you are, sometimes if I do it, I will make sure that the chapati gets torn off, clear. But when experts hand do, it gets rolled beautifully in a circular, very thin sheet. So, that is the difference in experience and practice. So, this is another application of shear strength. So, I will make a dough of these minerals and I will extrude them to get Vim bar, soap bar, lipsticks of different sizes, whatever, clear, papers of different sizes and so on. So, this is the structure of the kaolin. 1 nanometer is 10 power minus 9 meters. This is the formula for kaolin. Alumina silica sheets put together, typical spacing is 0.72 nanometer, and this could be because of the oxygen sharing, and typically 70 to 100 layers are there, and as I said, they will extend into infinity, and kaolin is a very stable material, and that is the reason it is used for making potteries. So, chances are that kaolin will not absorb moisture much, because there is a hydrogen bond between the two combination of alumina and silica, and hydrogen bond is a very strong bond, you can't break it so easily. So, that is the reason for making potteries kaolin or kaolinite is used, alright, and this is a stable system. Then comes halloysite. Halloysite is another mineral which is of kaolinitic family. This is hydrated and it is of tubular structure. Most of these minerals are either platelets or tubular structures. If you can remember this formula, you can remember the only difference between kaolinite and halloysite is that there are 4 water molecules which get added up to the kaolin, alright. So, this becomes hydrated. So, calcium oxide, put it in water, hydration occurs, calcium hydroxide get formed, alright. Is this okay? Then comes the montmorillonite. People have special interest in this because this is a mineral which is hyperactive. It has a lot of values, you know, in present day science and technology, and but it used to be treated as a curse some time back. So, you go to the central parts of India, Maharashtra, Madhya Pradesh, Karnataka, where you have black cotton soil. The constituent of the black cotton soil is montmorillonite. It has very strong affinity towards environmental changes. During rains, it will accumulate water in it, becomes fat, and when rains go, it shrinks. Any building which is sitting on the black cotton soil deposits, montmorillonitic soils is bound to get distress, crack, foundations will fail, and the reason is this is silica alumina silica combination, and in between the platelets you will have water, and this water is weakly attached because of van der Waals forces. So, I hope you remember from your 10+2 chemistry, hydrogen bond is much stronger than van der Waals force, correct. So, this is how it goes. So, the more strength and the more stability comes because of the weak bonds as compared to the kaolinitic material. So, because of this system, the water enters into these platelets, the spacings, and the water hunger for this mineral is extremely high, alright. It has a lot of value in agriculture, but as far as civil engineering practice are concerned, people want to bypass this because they do not want to keep any foundation on this type of systems. But in sports, it is becoming useful because this is what is known as smectite. Smectite is one type of montmorillonite which is to be added to make pitches very stable for the required duration, alright. And then you, as I was giving you the logic, captains they want to water the pitch after the first innings are over, second innings are over and so on, and they want to roll it with a light roller, heavy roller, so all the dynamics will come into the picture. A little bit more on the montmorillonite because this is of special interest. It is a highly reactive expansive clay. Please, as I said last time, it is not expensive, it is expansive, it expands, and this is the formula for the montmorillonite. N times water molecules indicates that N could be any number, clear. So, it has a special hunger for water. Bentonite is one of the montmorillonite which we discussed earlier. It is used in drilling, slurry trench design, leakages. Most of the putties which you use, you know, different types of putties which are used for sealing the cracks are made up of bentonite, and this shows thixotropic effect. And if you remember, this is the material which is normally used in nuclear industry for depositing or the disposal of the nuclear waste. Then comes the illite. It is another interesting mineral where the spacing between the alumina silica alumina sheets would be filled up with potassium ions. So, normally potassium ions go and sit over in between, and again this is a very weak bond as compared to the hydrogen bonding or van der Waals forces. So, this is how the mineralogy is taken care of. There is another mineral which is known as chlorite. So, this is a 2:1:1 type of a clay mineral, and we have vermiculite, we have attapulgite, and all these are the minerals which are present in the soils. Depending upon your requirements, you can work on them. Now, let me talk about the clay particle, because I wanted to start the discussion on particulate nature of soils. Clay particles are platelets, alright, and when they are platelets, they would have a fabric. As I defined last time, fabric is nothing but the texture, Now, this is a subject which is in focus, much more focus and attention of the researchers these days. Pharmaceutical guys, and I hope you understand, pharmacy is the profession where the money is too much both ways. They deal with this type of structures a lot. What is their interest? Can you imagine? Well, these are the structures which have been created in which I can fill anything. So, these are the porous structures. Now, what I am showing here are the platelets, which is a depiction of a clay mineral or a clay sheet. Now, clay sheets might sit like this, that this is the sheet, the face is touching the edge of another sheet and edge is touching the face of another sheet. This is what is known as edge to face contact. When I will start discussing the mechanisms of movement of water in soils, I will be referring to this as a flocculated structure. If you compact this soil, alright, suppose if I confine it in a volume and if I compact it, so all these platelets are going to get aligned, very obedient, alright. So, this is what happens. You must have heard about the card pack house structures, alright. So, the moment you take a card structure, you press it from both sides, compact it a bit, all the plate becomes aligned. This is what is known as a dispersed structure, face to face contact. So, face is in touch with another face, porosity is less as compared to the initial status. I will revisit all this. This is something which is normally used as scanning electron microscopy for those of you who will be interested in such studies. If you want to see the alignment of the particles or the fabric of the clay particles, a scanning electron microscope is the tool which is used to see what type of arrangement of the grains which I showed you is existing in the system. I am not going to go into details of all these things, these are slightly out of context for undergraduates, but you should be aware of because this is where the R&D is and this is where the stakes are for our profession. These are the images. I mean, just now I showed you some schematic diagram, and here what you can see is the kaolin fabric. Look at this. I mean, sometimes you must have seen when you keep the loaves of the bread one over the other, is it not? This is how it looks like. Look at the sheets of kaolin. These are the sheets of kaolin. Alright, they are just stacked one over the other, and there is a lot of porosity, pores which are getting created in the system. So, this is a typical soil fabric. So, fabric word is used for two things. One is orientation of the particles, shape of the particles, and the type of pores which are encased in them. You understand? So, sometime back I was discussing about controlled drug delivery, is it not? What would I like to do? I would like to inject drug into these cavities which are at nanometer level, and they become medicines for me. They go in the body and slowly they will release. So, gone are the days when people used to take pills and the capsules which used to react immediately, and that reaction used to be fatal for the body. Nowadays, you create a system through which the exgress means something which comes out, is slow, controlled, regulated, fine. So, imagine you need not to eat food, you just eat few capsules, what your astronauts do. In those minerals, they must have packed nutrition so much that each capsule will slowly release in your stomach and it will go in the blood vessels, and you can stay without eating anything for whole day. Is this correct? Another view of how the platelets look like, this is another fabric, beautiful plates stacked with each other. Look at this, edge to edge, alright. Look at this platelet and this platelet, edge to edge, face to edge, this is the face and this is the edge, okay. Bundles or the sheets of minerals lying one over the other, first story, second is, this is the first story, second story, on the top of this is there, complete stack is like this. So, face to face to face to face to face, clear. In between whatever space is there can be utilized by soil technologists. Just to give you a feel of this, please remember the scale, this is 200 nanometers, alright. So, all these studies are sub-micron studies. You have to have lot of patience, you have to have lot of time to sit down, take images, quantify them. Many of you who are trying to work on artificial intelligence associated with agricultural projects, there are a lot of projects going on in the country where by looking at the color, by looking at the shape, morphology, people are trying to work out on what type of agricultural dosage should be given to the vegetation. A lot of projects are going on. They use many times SAR photogrammetry also, SAR images, remote sensing data they use. So, all these are can be utilized by the guys who are in the profession. Those of you who might be interested in microbial studies, because I talked about microbes, I thought I will just show you how the microbes look like. Can you identify these microbes? All these white capsules which you are seeing over there, these are the microbes. 20 micron is this much. So, imagine the size of the microbial activity. This would not be even 1 micron or something like that, alright. So, nowadays people are talking about this a lot. This is at 5000 magnification of the image, scanning electron microscopy. This is a closer view. I just wanted to see how the clay platelets are adhering the bacteria. Densely populated colonies of bacteria in the soils, So, what they are going to do, what type of failure they are going to create. This is a profession which is known as forensic geotechnical engineering. Why systems are failing, though they were designed in the best possible manner. Clear? So, we can show what type of movement and where the concentrations are and the way you want to interpret it. I mean, you become a forensic expert, why failure has occurred. Then comes the X-ray diffraction, because you must have noticed that most of the minerals have a elemental composition and they are oxides mostly, SiO2, Al2O3 and so on. So, the question is, how are you going to find out the oxide composition of the soils? So, this is what is done with the help of X-ray diffractometers. We call them as X-ray diffraction analysis, XRD analysis. How many of you know Bragg's law? What is the application of Bragg's law with respect to this? So, when you are studying 10+2 physics, you simply mugged it up, no? Now, the applications are coming. So, your 2d sin theta equal to n lambda, agreed? So, what is n? Number of wavelength or whatever, lambda is the wavelength, and 2d sin theta, what is d? Distance between two layers of particles, stacks, very good. So, atomic distance, clear, and sin theta, theta is angle of incidence of the X-rays. So, you take the sample, keep it on a platform and allow the X-ray to fall on this with some angle theta that you can measure, and you know what type of wave you are using, which type of filter you are using, copper K alpha or nichrome, chromium, whatever that you know. So, you know the wavelength of the wave and it is hitting the sample, and whatever the reflected wave is, if I can capture it on a electron sensor, or if this electron beam is captured on a analyzer, I know the pattern. So, I will show you what type of patterns you get, and then you can know quickly what are the elements which are present in the system. So, whether you are from a gem jewelry shop, or you are a artist or whatever, everybody uses XRD analysis. You must have seen, you go to jewelers, what do? They will put the jewel there and they will immediately tell you what is the component of the carbon, how much is the gold, silver and so on. I will show you how to read these things quickly. So, if you want to know the molecular lattice and crystal structure of the minerals, then you have to do XRD analysis. Now, this is becoming more research oriented. I hope you are realizing the concepts are same, but I want to identify, you remember minerals, how to identify them, all these are identification tools. Then quantification, softwares are there nowadays, you are lucky that you just feed the data and you know what is the composition of the soil in terms of the minerals, and then I can give a sort of a prescription how to utilize this. There is something known as the DTA, differential thermal analysis. So, every mineral will have a specific heat and that is the keyword, clear. So, whatever minerals you are using, so suppose if you join tomorrow oil and gas industry, where they are very much eager to design slurries which can be injected up to let us say 10 kilometer deep inside the seabed, so that I can seal the well. check it on net. Deep cementing slurries is a beautiful subject, a lot of money is there. There's a lot of companies who sponsor and who hire people for designing deep cementing slurries. So, what should be the component of these slurries, how, what type of liquid should be utilized, what is their thermal property, what is their pressure bearing, and all these things you can study by doing these tests. So, typical diffractograms, you find all these type of diffractograms normally in hospitals, is it not? Or when you meet a surgeon, what he does or she does. So, cardiogram is a sort of a record of how your heart is functioning, same thing we are doing here. So, D is the atomic spacing in Bragg's law, that is what I am trying to find out. So, these typical graphs look like this. On y axis you have relative intensity and the x axis you have 2 theta value of a ray, clear. What I have to do is expose the sample, get this type of a diffractogram. I will be knowing theta value and the peaks of the minerals which are present in the system. Fortunately, all this is done nowadays with the help of softwares. So, if you click over here ICSD, you will go to a web page which deals with the database of minerals. There was a time when my students used to sit down and match the D value up to 4th decimal place. They used to spend months together. Now, things are very state of the art. It is a matter of few minutes when you can get the results, but yes, how to use the results judiciously is a big question. This is what is known as inorganic crystal structure database. Quick reflection of the graphs which you are going to get. Sometimes you get peaks, crystalline material, very inert. Sometimes you get hazy pictures without any clear peaks. So, that is the difference. This type of material is a good glassy phase material. This can be utilized as a cement. The more and more peaks you have, the more and more crystallinity, very stable system. So, as a geotechnical engineer, I would like to utilize the soils which are crystalline in nature, not amorphous. This is the amorphous nature, this is the crystalline nature, clear. But suppose if I change my profession and if I am doing, let us say, medicine, pharmaceuticals, I do not want crystalline things, these are going to scratch my intestine from inside, is it not? I can't use it in the detergents, I can't use it in washing soaps. So, what I have to do? I have to use a amorphous phase of the material which is soft, gentle, very high cation exchange capacity, very high surface area, clear. So, this is the difference, depending upon your profession you can select the right one. Okay, so, having done the minerals, now let me touch upon the particulate nature of soils. Soils by virtue of their nature are particulate in nature. Until now you have done fluid mechanics, alright, and at the same time you have done solid mechanics also. Ever wonder that why should we study the mechanics of soils? Very interesting philosophy. It is a wonderful material and it is a all rounder. So, most of the captains prefer all rounders, no, in their team. Given a chance, this material can behave like solids and it also can behave like fluids. Did you understand this concept? This was the genesis of the thesis of Rakshit. Unfortunately, the conventional geomechanics only deals with this state, but most of the projects in civil engineering you will find are related with slurrification of the soils, making different types of emulsions, different types of slurries. I give you an example of last time, dredging. So, those of you who are going to be an expert in dredging would make a slurry of the soils which is going to be in the fluid state. So, I hope you can realize this interesting behavior of the soils. The material you can use the way you want. What is controlling these two transitions? The moisture content. You keep on increasing the moisture in the soils, they get transited to a fluid state, they start flowing, and hence you have to study the fluidity of the soil. So, we will use a term which is known as flow index of soils when we characterize the soil, alright, because it is in a flowing state. I told you the examples in modern day geotechnical engineering practices, wherever you want to make a slurry, bentonite, make a slurry, put it in the piling, put it behind the retaining walls for stability, and so on. Dredging, solids. Now, this is what actually we are going to concentrate more on. If I start from the fluid state of the soils and if I keep on drying the soil, it gets converted to the solid state, and again the interplay of the moisture. Now, what is meant by the particulate system is basically soil particles are not bonded. So, when we say particulate nature, that means the soil is treated as a consortium of particles of different sizes, different shapes, different morphology or whatever. So, these soil particles are not bonded strongly, as in case of the metal crystals. So, they are free to move freely. The second analogy is that soil particles are solids and hence cannot move freely. So, this is the state of the solid system, this is the state of a fluid system. Now, a little bit of the mechanics of the material, because we are talking about the particulate nature of the soils. So, henceforth now the discussion is going too much mechanistic. Those of you who are having complaints that it's all abstract, theoretical, now should gear up for learning the mechanics part of this. I am sure you will find it equally critical, if not, I should not use the word difficult. You must be hearing the names of finite element, discrete element, continuum and all these things. Some of you might be working also or might have worked during your internship with the different universities. There are many guys who work in the quantum mechanics, discrete mechanics. So, soils by nature are a consortium of discrete particles. Is this statement correct? Discrete particle means each particle has its own identity. But the beauty is that all these particles put together form a continuum. Is this okay? Fine. So, suppose if I consider a control volume, and for the sake of simplicity this contains soils. the way I am showing it is a general soil, rounded particles, very discrete particles, a granular system, and this system is being compressed by applying a pressure, and your JE and all these things you must have done hundreds of example problems like this. But there is a difference now. What is the difference? The material is new, this material you have not studied yet. Had it been fluid, you could have done easily pressure diagram, constant pressure and hydrostatic pressure, and you will sum it up and you say this is the pressure. Now the tricks start. So if I am applying stress, normally I define normal stress as sigma. This is normal stress. Now the system is very moody. It all depends upon the confinement. Learn these words, because unless you learn these words, there is no fun. Clear? So the subject makes you understand the terms and the terminology which are being used in the most technical way. Now this is the confinement. Clear? Had it been a homogeneous system, I use the word discrete system. It is not homogeneous system like fluid, not like gases. Imagine if the confinement is rigid. You have done all this mechanics, rigid body mechanics, solid mechanics, you have done, you are masters in that. Now suppose if I put a condition that this system is not rigid and this becomes flexible, now what you will do? That is what we are going to study. You agree? Why it is flexible now? What I have done is, very conveniently to make you understand what we are discussing, this is the ground level, you remember, and I have taken a small control section out of this. In ground, very rarely you will find that the boundaries are going to be rigid unless you place sheet piles. Agreed? Now these sheet piles are the elements of the steel which are, you must be seeing all along the highways. They, what do? They embed two sheet piles, tin sheets, and then they can excavate in between, they make basements, underground space. Metro is being done right now, go and see that. So the chances are that you are not going to have the confinements which are rigid. Had this been rigid, and if I asked you how the pressure is going to get delegated inside the system, it was fairly simple. You would have taken a element out of this and you would have zoomed it, saying this is a particle, this is a particle, and when I am compressing them, they come closer to each other, and what is going to happen? If the compressive forces are extremely high, then the crushing strength of the grains, is this okay? If the confining stresses are higher than the crushing strength of the grains, what is going to happen? Up to a certain limit they will come close to each other, the pressure intensity will keep on increasing at this point, and then the pressure will increase so much that this might be the situation. You understand? They will come closer to each other first because you are compressing them in a rigid system. Lateral deformation is 0. The only possibility is the whole system will move down, get compressed. Particles will come closer to each other. Beyond the crushing strength of the particle, the contact remains, the stress keeps on building over here. The stage comes where the crushing takes place. This is the crushing of grains. One mechanism in geomechanics. You are designing the building foundations, the stress intensity is so much which is much more beyond the crushing strength of quartz. 20 MPa. The particles will get crushed. If I draw the free body diagram, there is a normal stress acting over here, there is a shear stress acting over here. Clear? The normal stress is higher than the crushing strength, and hence this is the first mechanism which controls the deformation of the soils. Is this part clear? Deformation of the soils. Now, when we talk about deformation, it is understood that we are talking about the granular system. There is another possibility that I might be having some fine grained particles also in this. So, these are the fine grained materials, clays, silts, fine sands. Now, what is going to happen? They provide a sort of a cushion. So, this type of situation will not occur. I can idealize this situation as a clay platelet which is supported on two coarse grained materials, and I am sure you are doing this analysis a lot in structural analysis, is not? The loading comes and you know what is the deformation of this system. If I keep on increasing the stresses, the stage will come where the clay platelet itself will break. So, this is the second deformation mechanism for the soils. We call it as a particle crushing. This is what is known as particle bending. And the third one is what is known as particle shearing or rolling. In this case, the chances of rolling are going to be absolutely 0. Why? Because I said this is a confined rigid system, there is no lateral deformation. The only possibility is the more and more stress you apply, the load which you are applying is getting converted into the form of the stress, and this stress might create a shear stress, and because of the crushing incapability of the material, the system crushes. The moment this confinement becomes flexible, which is the situation in most of the cases, now what is going to happen? And if I take the particulate behavior of the soils and suppose there is a consortium of particles. Now imagine if I am loading it from the top, the boundaries are flexible, it is a semi infinite soil mass, both sides the soil mass exist infinite, clear? What is going to happen? This particle will push it, create some space, this particle gets shifted in the lateral direction, and in the process it might so happen that one of the particles might roll over and come and sit. Let me create few more particles to make my point clear. Okay. The moment you compress it, you apply loading on this, the chances are this particle will go and come and sit over here like this. This may come out and this may come and sit over here like this. This is what is known as rolling process. This is what I was writing here. So, this is the C mechanism. So, deformation of the system which we were talking about, which is a particulate in nature, depending upon the boundary conditions, would be either A, B or C or a combination of the three. It's okay. So, this would be either A, B, C or combination of A, B and C. Depending upon the constituents of the material, the fraction or the the type of mechanism which is going to supersede others would change. These are the hypotheses, and that is why I thought let me wake up all of you who are sleeping, because henceforth the entire discussion would be only in this form. So, what I have done? I have done two idealization. First is the material, granular material encased in a rigid box, the boundaries are not going to deform. When you make wells, foundation wells for very important bridges like Brahmaputra valley, there are so many bridges which are being done of strategic importance during Modi's regime. Most of the wells are being done by this concept. What I have to do? I have to create a confinement deep inside the river bed, insert something so that the soil does not deflect, move out of the control volume, and lay the foundation on the top of this. You are happy now? The foundations are coming in picture. So, onshore when you are working, the situation could not be like this, and this system might be flexible, and hence all this is going to happen. So, what we have done is material approximation and the mechanism approximation.